Hello and welcome to Excel Mathematics TV. This presentation will be about prime factorization. To learn more about prime factorization, we need to know what prime numbers are. Let's talk about prime and composite. Have you ever heard of these two words before? Let's see what similarities and differences they have. Prime and composite numbers are both whole numbers greater than 1. The difference between the two is that a prime number has exactly two factors, 1 and the number itself, while a composite number has more than two factors. For example, 2 is a prime number because it has exactly two factors, 1 and 2. Can you think of any other factors other than the 1 and 2? No, right? So it's considered as a prime number. Can you give examples of prime numbers? 3, 5, and 7 are all prime numbers. They don't have any other factors than 1 and themselves. What about 4? Is it a prime number? No, it's not. 4 is a composite because it has more than two factors. Its factors are 1, 2, and 4. 6, 8, and 9 are also examples of composite numbers. There are numbers that don't belong to any of these two types of numbers. 0 and 1 are neither prime nor composite. Let's see if we understand what a prime number is and what a composite number is. Let's identify if the given number is prime or composite. The first number is 14. To know whether 14 is prime or composite, we need to know the number of factors that it has. So, let's identify the factors of 14. 1 is always a factor of all prime and composite numbers. 1 times 14 is 14. And 2 times 7 is 14. Therefore, the factors of 14 are 1, 2, 7, and 14. As you can see, 14 has more than two factors. Thus, 14 is a composite number. Next, we have 19. Is 19 prime or composite? Let's find out. First, we need to identify the factors of 19. As always, 1 and 19 itself are factors. But there are no other factors other than 1 and 19. So, the factors of 19 are 1 and 19. It has two factors. Thus, 19 is prime. Do you want to see some more examples? Let's have two more. Is 31 prime or composite? We decide based on the number of its factors, so we need to identify the factors of 31 in order to know whether it is prime or composite. Just like the previous examples, think of numbers that will result to 31 when multiplied to each other. 1 and 31 are factors of 31. Are there any more factors? After thinking, we can say that the only factors of 31 are 1 and 31. So, 31 has two factors. Thus, 31 is a prime number. Lastly, we have 48. We can determine the factors of 48 by thinking of the numbers that will result to 48 when multiplied. We have 1 times 48, 2 times 24, 3 times 16, 4 times 12, and 6 times 8. From there, we can determine all the factors of 48. The factors are 1, 2, 3, 4, 6, 8, 12, 16, 24, and 48. 48 has many factors, and they are obviously more than two. Thus, 48 is a composite number. Now let's go to the main lesson. Let's study prime factorization. We already know what prime numbers are and how to tell whether a number is prime or not, so this should be easier. What is prime factorization? It is finding all the factors of a number. These factors must all be prime numbers. There are several ways of getting the prime factors of a number. One way is by using a factor tree. We just need to follow 3 simple steps. First, write the given number at the top of the tree. Then find any pair of numbers that are factors of the given number. Continue factoring the numbers until we reach a row of prime factors. Don't stop factoring if there are still factorable numbers. Another way of finding the prime factors is by using division. In this method, there are only 2 simple steps. First, divide the given number by a prime number. Then, divide the quotient we got from the first step by another prime number. Continue dividing until we get a prime quotient. It's time to practice what we learned and solve some examples. Let's find the prime factorization of 36 using the 2 methods. First, let's use the factor tree. There's a tree-like figure here, and we need to write 36 at the top of the tree. Think of the factors of 36. What 2 numbers can we multiply to get 36? 6 times 6 is 36. So There are factors of 36. Can you still remember the steps we discussed earlier? What is the next step? We will continue factoring until all the numbers at the bottom are prime. As you can see, these are all prime numbers. So this is the prime factorization of 36 using the factor tree. Let's try using the other method. That is by using division. All we need to do here is divide and divide until we get a prime quotient. So let's divide 36 by a prime number. 3 is a prime number, right? So let's start by dividing 36 by 3. Doing so will result to a quotient of 12. This is not yet a prime number, so we need to continue dividing. Let's use 3 again. 12 divided by 3 is 4, but 4 is also not a prime number. So divide 4 by a prime number, which is 2. Doing so will give us the quotient 2. Is 2 a prime number? It doesn't have any other factors aside from 1 in itself, so it is a prime number. This is where we stop dividing because we already got a prime quotient. The divisors we used are 2, 2, 3, and 3. If you noticed, the order of factors found using the factor tree is different from the order of factors found using division. But remember that multiplication is commutative, which means that the order does not matter. Thus, the prime factorization of 36 is 2 times 2 times 3 times 3, or the square of 2 times the square of 3. Let's have another example of finding the prime factorization. Let's find the prime factorization of 64. This is the prime factorization using the factor tree. Just follow the same procedure we did in the previous example. Put the number at the top of the tree and factor it until all the factors or the numbers at the bottom of the tree are prime. Using division, the divisors that will be used are 2, 2, 2, 2, 2, and 2. We have 6 2's. Thus, the prime factorization of 64 is 2 times 2 times 2 times 2 times 2 times 2. Or to make it simple, we can write it as 2 raised to the 6th power. We can also apply the knowledge about factorization in factoring an algebraic expression. Let's factor 9mn. We can use a factor tree in finding the factors of the algebraic expression. This is the factor tree of 9mn. Thus, 9mn can also be expressed as the product of 3, 3, m, and n. Let's have the last example for this lesson. Let's factor the algebraic expression 16y squared z. Just like the previous algebraic expression, we will also use the factor tree. This is the factor tree of 16y squared z. Thus, the factors of 16y squared z are 4, 4, y, y, and z. That's all for today's lesson about prime factorization. There are a lot of areas in mathematics where prime factorization is useful. I hope you keep in mind what you've learned. Thank you, and we'll see you next time.